It was a short film. Sorry. I was eating some bulgogi. Make sure I don't have any food in my beard and my face. And yeah, lost track. Was digging in. Anyways, yeah, so this is Skip Elsheimer here. And this is the AV Geeks Lunchtime Streaming Show. And that was Tropical Opossums. Cute. Man, there's a lot of YouTube videos of cute little animals. Shrews, sloths, etc. I guess sloths are big animals too. Anyways, so that predates it. This is something that was probably shown in theaters initially as a short subject, and then was printed to 16mm and distributed for educational markets or what have you, via the Mogul Brothers Film Library. Okay, the next film that we have set up, speaking of animals, this is Animal Tracks and Signs. Enjoy.
Were made a long, long time ago by a dinosaur. And these footprints in the snow were made just a minute ago by a boy and his dog. These hoof tracks were left by a deer. And these bushes, with the parts eaten off, are a sign that deer have been eating on them. Indians depended on wild animals for much of their food. To help them find their prey, they studied the tracks and signs that all animals leave behind wherever they go. Animals leave tracks in snow, on the sand, and in mud. Some other signs animals leave for us to see are chewed twigs, bits of fur, nutshells, cocoons, and eaten leaves. Many wild animals today, especially those living near cities, are nocturnal. That is, they come out of hiding at night when people are not about. Even though we don't usually see them by day, we can tell they've been around by the tracks and signs they leave. Have you ever looked around your backyard to see what animal signs you can find? In the curled cabbage leaves, Sue has found aphids. Aphids live on leaves. Johnny notices something in front of the mower. A garter snake has shed its skin. A snake's skin is a sure sign a snake has been there. And Johnny and Sue spot it wriggling through the grass. The children know that some snakes are poisonous, so they're careful not to pick this one up. By learning to look for their signs, you can find out what animals live in your neighborhood. Sue has found a piece of blue eggshell. Can you help her guess what bird laid the egg? Sue hears the mother bird chirping in the nearby tree. And now she can see where the eggshell came from, a robin's nest. Sounds animals make are another sign that they are near us. The sound of buzzing of paper wasps and other stinging insects warn us to keep away. The woods and fields are usually the best places to find animal tracks and signs. This black feather that Sue has found. This nest high up in the tree. Young birds with long beaks in the nest. And the mother bird's call. All these are signs that tell us a crow has its nest here. You too can find out what animals live in your neighborhood by mixing up some mud and making an animal signs trap, as Johnny and Sue are doing. After stirring the mud until it looks like soft ice cream, Johnny and Sue take it to the nearby woods. Sue has brought along her father's trowel to smooth out the mud after it has been poured into a hollow in the ground. But any flat, smooth board you can find will do just as well. After smoothing out the mud, the children bait their trap with a nut. A piece of bread or candy can also serve as bait. Johnny and Sue hide to see what will happen. Their first visitor is a curious squirrel. Johnny wonders if it has seen the nut. There it goes, right onto the mud trap, leaving tracks for us to see. Sue can hardly wait for the squirrel to finish eating the nut and leave, so she and Johnny can look more closely at the tracks. Johnny points to the marks left by the squirrel's sharp claws, which it uses for climbing. Sue looks up the squirrel in her animal tracks book to see if the pictures are the same as the real footprints. With a book like this, it's easy to identify animal tracks. Before going home, they smooth out the mud again to see what animals might visit their trap during the night. The next day, they anxiously hurry back to their animal signs trap. Johnny finds these footprints clearly visible in the mud. Using the animal tracks book, Sue compares the long marks in the mud with the drawings in the book. Although animals don't always leave clear tracks that look exactly like the pictures in the book, Sue thinks these belong to a cottontail rabbit. At the edge of the trap, they find another set of prints. They can tell these tracks belong to a red fox. Johnny and Sue imagine that a hungry fox, with its good sense of smell, had picked up the trail of the rabbit as it ran through the woods. The rabbit easily crossed the mud trap and was soon followed by the fox. Do you think Johnny and Sue guessed right? Another animal which crossed Johnny and Sue's animal signs trap was this slow-moving turtle on its way through the woods, leaving a trail that's easy to see. Can you tell which is the mark left by its long tail? Just by walking through the woods and looking about you, you may discover other signs of animals. John has found a cocoon, a sign of a caterpillar. Caterpillars make cocoons while changing into butterflies and moths. The caterpillar in this cocoon has already changed into a moth. Now it will leave its protective shell and spread its wings to dry before it can fly. This web is the sign that tent caterpillars live here. Can you see why they are called tent caterpillars? Many wild animals build their homes by ponds and streams. This house in the water, built of reeds and rushes, and these tracks, with the mark of a tail long enough to reach the ground, were made by a muskrat. Muskrats seldom leave the protection of their homes and the water. Their heavy, oily fur keeps them warm and dry. The sandy beaches along a lake or at the seashore are also good places to find tracks and signs. Johnny has never seen these tracks before. Following the tracks, he and Sue soon find the animal. It's the horseshoe crab, its many legs, tail, and shell, leaving a trail wherever it goes. The next time you go for a walk, look around. Perhaps you can find these tracks and signs. A garter snake skin, rabbit tracks in the snow or mud, crow's eggs, a mole's burrow, or even a squirrel's den.
Intentionally, I have a bunch of EB, Encyclopedia Britannica films, set up to watch. I was just picking, just like, oh, I haven't seen this one. We haven't shown this one. Oh, we haven't done this one. I noticed they were all EB. And also, I'm trying to set up the scanner for showing you some commercials, but the splices are very, very poor on this, so I'm going to have to do some more work. It might not happen today. Anyways, let's learn about the Vikings, their life, and their conquests. Enjoy.
Our sea steed through the foam goes prancing, while shields and spears and helms are glancing. From fjord to sea, our ships ride free, and down the wind with swelling sail, we race before the gathering gale.
So sang the sea-roving adventurers of the early Middle Ages, known as Vikings. The Vikings came from Scandinavia in the far north of Europe, from the countries we call Denmark, Sweden, and Norway. The Northmen sailed by the sun in the daytime and the stars at night. In their sturdy longships, they traveled farther than any other sailors of their time as they fared to their adventures of commerce and war.
Thou hast the art, O king, of sailing stormy seas and living long under the sea-sprayed tent.
The skills of seafaring were passed on from father to son. From early youth, they learned the secrets of the winds and currents, rowing when the air was still, using the square sail when the breeze was favorable.
And down the wind with swelling sail, we race before the gathering gale.
From the 9th to 11th centuries, these pagan pirates, warriors, colonists, and merchants poured over much of Europe. They began by crossing the North Sea and making raids on Christian settlements.
From the fury of the Northmen, good Lord, deliver us.
and destroyed towns, monasteries, and castles along the coasts and river banks. Sometimes they left as quickly as they came. Other times they stayed on to build their own settlements so they could continue their attacks further inland. Neither the prayers nor the defenses of the Christians could stop the tide of the Viking onslaught. The solitary raids grew into big invasions as petty chieftains joined together under strong leaders, and fleets of longships assaulted the largest centers of the Western world. During the Viking Age, the ships that sailed out of the north used two main routes, the East Way and the West Way, which took them to the two great empires of Christendom. The Vikings reached the farthest corners of the known world as they raided, conquered, traded and discovered, and then stayed on to settle, colonize, and rule. From Ireland to Constantinople, they left a trail of destruction and plunder. They also left a new way of life, for northern civilization was young and vigorous, as yet untouched by Greek, Roman, and Christian traditions. The invaders lived in the spirit of myth and legend, performing deeds of great boldness and valor, loving adventure and seeking fame and honor. They were proud and independent, yet from the peoples they conquered, they learned many new things, and their captives gained fresh ideas of freedom and equality, for even slaves had recognized rights in Viking society. The Skalds, the poets and storytellers of the north, shared the life of the sea rovers and told of their exploits. In noble rhymes, the Skald would praise their skill in battle or lament the heroic death of a young warrior.
Much the sea from me hath taken, cruel to count my family's loss. For my son hath come to an end, like a tree overturned by a storm. Sad is he who bears the corpse of dear kin from his dwelling place.
When a chieftain died, he was often buried in his own ship in a special burial chamber. Here were placed all the possessions of the dead man, all the things needed for his next life. The Vikings honored their dead, even though they had no fear of death itself. They believed their ships would carry them to the spirit world, to Valhalla, mythical resting place of Norse heroes. The ships would be carried ashore and covered by huge mounds, such as this, graves from which the ships have now been dug up and whose contents tell us a lot about the daily life of the Vikings, a people who left no written records except for brief inscriptions in the ancient runic alphabet. These were often carved on huge stones and told of an important person or great event. These early Scandinavians were not only seafarers, they were also farmers. Wherever they lived, they worked small plots of land, using a crude type of plow to raise the cereals and hay which they needed for themselves and their livestock. In their farming methods, they differed little from most other people of Europe in the 9th and 10th centuries. The great difference lay in the fact that they were independent farmers, owning their own land and moving about as freely as they chose. In peace and war, these people were one another's equals. Men did the heavy work, such as the threshing of the grain, while women did the house chores like grinding the grain for use in cooking and baking. Cooking was done over an open fireplace in the center of the Vikings' one-room wooden houses. Their households were large and family ties very strong. The idea of kinship, of loyalty to one's blood relations, was of great importance. "Bare is the back of the brotherless," says a proverb of the time. A man's first allegiance was to all his kinsmen rather than to a chieftain or a king. From earliest youth, children followed their elders in play and in work. Girls learned to help their mothers, who in addition often had slaves to assist with the many jobs. Viking women ran their households with a firm hand. Both in and out of the house, women in the north had more equality and independence and played a greater role than other women in medieval Europe. Grandparents shared the family home with their sons, daughters, and grandchildren and helped them with the various household tasks. One of the most important of these was the spinning of wool, which was the usual material for clothing and prepared entirely by hand. It would first be spun into a coarse thread and then later woven into cloth on a simple loom. Gambling and game playing was a favorite recreation of the older men. They could sit and occupy themselves for hours, playing a table game very similar to checkers or chess. The large common room with its open hearth was the center of all domestic activity. There were no chimneys in these Viking houses, and the smoke went out through an opening in the roof. During the short days of the northern winter, the men would spend their time hunting or making tools and other implements. Besides being expert shipbuilders, they were skilled craftsmen in both wood and metal and able to make fine silver jewelry. Meals were eaten at a long wooden table, and the head man of the house usually sat in the high seat or place of honor. The Vikings had frequent feasts, particularly during the long and dark winter months, while they waited for the snows to thaw and the iced-in fjords to open up. Guests were always made welcome, and a family was proud of the hospitality it could offer. The men loved to eat and drink heartily, and would entertain themselves by telling and listening to stories and sagas of exciting adventures and dangerous sea journeys.
This did say my mother, that for me should be bought a ship to share the life of Vikings. And down the wind, with swelling sail, we race before the gathering gale.
The Norse sagas were first written down several hundred years later in Iceland, discovered and settled by the Vikings in the middle of the 9th century. From here, the Norsemen sailed even farther across the Atlantic to found a colony in Greenland. The saga of Eric the Red, who settled in Greenland, speaks of his son Leif, who navigated even farther to the west to explore the far-off shores of North America, which he called Vineland. Other sagas tell of permanent Viking settlements in Western Europe, in Normandy, in Ireland, and above all in Britain. In the Danish colony known as the Danelaw, the Danes owned the land and imposed their own laws. From here they spread and conquered the Anglo-Saxons, uniting all of England under one ruler. But in the east, the Swedes were looked to as protectors and known as Varangians, a Russian word denoting a merchant or a trader. Their commerce with Constantinople had many far-reaching results. The Swedish traders were received by the Slavonic river towns as rulers who gradually accepted the religion and culture of the Byzantians and formed an empire of Nordic princes and Slavic subjects, which became the foundation of the later Russian Empire. But in the Scandinavian countries, the coming of Christendom marked another phase in the clash between North and South. The saga of Olaf the Holy, King of Norway in the early 11th century, relates how he fared throughout the land, proclaiming Christian law and holding Thing meetings with all his subjects. The Thing was the legislative assembly of the Vikings, a gathering of all free men to make laws and settle disputes. Olaf's saga tells of his Thing meeting with the freemen from the Dales, and their chieftain Gudbrand.
The sun had not yet risen when the king and his bishop arrived at the Thing place and saw the Dale folk approaching with their pagan idol, Thor, the god of war and thunder, the carrier of the hammer. The idol was placed in the middle of the Thing mead. On one side was the king and his company, on the other the men of Dale. Then Gudbrand challenged Olaf and his invisible god. Where is thy god now? It seemeth to me that your swagger is less, for now our god is come. Thor, who can be seen. So drop your folly and believe in our god. Then the king replied, Thou threaten us with thy god? But lo, look ye now and gaze eastward. There now fareth our god with a great light. As the men looked to the dawn, Olaf quickly had their idols smashed. When the Dale folk saw their god destroyed, they first rose and fled in panic. But later they reluctantly returned to take christening, rather than do battle against the king and his all-powerful Christian god.
Like all else in the north, the Christianity of Olaf was fierce and strict. Yet, while the Vikings were altering the life of southern Europe, the church was beginning to tame the fury of the Northmen. As the new religion spread across Scandinavia, the Viking period of expansion drew to a close. From coasts such as this, the Northmen, in less than 3 centuries, had carried their new and vigorous civilization across the whole of Christian Europe. Now a new era was being ushered in. Long ships were becoming merchant vessels and northern waters busy routes of trade. In Scandinavia, national states ruled by strong kings were beginning to emerge. Abroad, the Vikings had hastened the development of feudalism by forcing the South to organize under strong rulers, at the same time adopting many Christian ways and customs.
So perish the old gods, but out of the sea of time rises a new land of song, fairer than the old.
Viking seafaring skill had brought the peoples of Europe into closer contact and laid the foundations for the maritime cities of the north. Today, the Viking age has vanished, but its spirit of adventure and discovery lives on as part of our common heritage.
Sing no more, O ye bards of the north, of Vikings and of Jarls. Of the days of old, preserve the freedom only, not the deeds of blood.
Yeah, pretty great film. Shot on location in Norway. Yeah, not bad. Kind of gloss over some of the raping and pillaging, but interesting nonetheless. So I've got a film set up here. This is where we geek out a little bit and go into a niche type of film. This is called Design for Manufacture, and it is about machining parts. And machining is basically you get these plans that somebody draws, and then you use various pieces of equipment to cut away the metal, drill holes, etc. And they're often made on demand. They're not cast. They're basically for specific pieces of equipment. And this is where 3D printing has been kind of stepping up a little bit, although obviously they don't do it with metal, but they're getting better. And the CNC, I think, little robots can do a lot of the machining that a human used to do. But there's still jobs out there in the world for machining in the U.S. So here is design for manufacture. Enjoy.
This drawing is completed. The design engineer's signature guarantees that this part will fit, that it will perform its function, and that it will stand up to normal and sometimes not so normal wear and tear. This is how the design engineer visualizes the part. The drawing is merely a vehicle whereby he communicates his thoughts and specifications to those who are concerned with production. The drawing must be concise, complete, easy to read, and easy to understand. It must take into consideration the capabilities and limitations of the men, hand tools, and machine tools available for production jobs. For instance, this 1-inch bore must be concentric within 1/1000th of an inch to this diameter. According to this note. Without this note, the degree of required concentricity would be unknown, which might result in an unacceptable part. The engineer inserted the note because his calculations showed that the specified concentricity is necessary for correct functioning. But to accomplish the concentricity, a separate and rather expensive operation is required, as will be shown. This balancing of expense against performance is at the core of almost all engineering decisions. It requires knowledge of the factors behind the expense as well as the factors which affect performance. In order to understand the expense factors, the engineer must be familiar with the tools and processes which will be used to produce according to his drawings and specifications. This film will show some of the tools and machines used to produce a part according to this drawing. The material is specified as SAE 1018. The overall diameter is 10 to 20 thousandths less than 3 inches, which permits the use of standard 3-inch bar stock. A piece of bar stock is sawed off. The stock is delivered to the lathe operator together with the drawing and a job order. And mounted in the lathe headstock. The lathe turns the piece while the tool is fed against it, either by hand or with power. The speed selector of this lathe allows a wide range of spindle speeds, from 850 to 20 revolutions per minute. The spindle may be rotated clockwise or counterclockwise. The selection of speed and direction depends on the type of material, workpiece diameter, and type of cutting tool. A chart is used to determine the correct speed and feed. This tool bit is selected as the proper one for the first cut. It is clamped in the tool holder of the lathe and moved up to the workpiece. The feed dial of the lathe allows the machinist to move the tool bit to within 1/1000th of an inch of the desired depth. The primary object of this rough cut is to remove material as rapidly as possible. Lathe spindle RPM, tool bit, and tool feed have been selected for that purpose, and material is removed to approximate the desired shape of the part. The finish cut, which aims at the specified 1-inch diameter, is now made. The more critical the dimension, the oftener the lathe must be stopped for checking the measurement. Such stoppages take time and therefore cost money. The engineer must know when the desired result justifies such cost. Here a neck is being machined using a specially ground tool bit. Another special tool bit is clamped in the tool holder for the purpose of cutting the thread. The lathe spindle RPM and the longitudinal tool feed are synchronized to produce the desired thread, 3/4 inch major diameter, 10 threads to the inch. Class 3 fit was specified. The machinist must therefore proceed with extreme caution, take small cuts, and stop the lathe frequently for checking using a specially hardened and ground gauge. All the preceding operations were performed in one lathe setup, but we now have to reverse the workpiece in order to bore the other end. A dial indicator has been mounted to bear against the outer surface. The drawing specifies a maximum of 1/1000th of an inch total indicated reading, TIR. So the workpiece is rotated by hand and the chuck adjusted until a specified concentricity has been found when the chuck is tightened. Now the 1-inch bore can be cut in the lathe within the specified concentricity. A special telescopic gauge is used to check this inside dimension. Then the face is machined. All operations which may conveniently be performed on a lathe have now been completed. Almost every workpiece requires one or several operations on a milling machine, which is one of the most versatile of machine tools. Basically, it consists of a spindle to turn the tool and a table to hold the workpiece. The table can be moved up or down, sideways, or back and forth by hand crank or by power. The cutting tool is secured to the spindle. It may be rotated in either direction. There are many different types and designs of milling cutters on the market. They are available in various angles, diameters, lengths, numbers of teeth, and materials designed for the many possible operations which may be performed on a milling machine. Our workpiece is lined up on the milling machine table and secured to it by means of a vise. this setup on the milling machine, we plan to machine these flats and this keyway. This calculator gives the spindle RPM and the rate of feed of the workpiece. The flats are now being milled. During the rotation of the cutter, each tooth cuts a chip out of the workpiece until the entire flat has been machined. An end mill has now been mounted in the spindle, and the keyway is being milled. The next operation is machining this timing slot. The basic milling machine is generally used for machining flat surfaces, but this timing slot requires that the workpiece be fed along an arc against the cutting tool. This can be accomplished by attaching a rotary table to the milling machine table. The workpiece is secured to the rotary table and aligned with the center of the milling machine spindle. The milling machine table, with the rotary table and the workpiece, is then located in relation to the cutting tool for the specified arc radius. The rotary table is turned by a hand crank, and as it is rotated, the tool cuts the desired arc-shaped slot. The milling machine table with the workpiece may easily be relocated for drilling these holes, because in the present setup, the relationship between the workpiece center and the milling machine spindle center is known. The dimensions of the holes are specified here. There are 4 holes, one of which is counterbored and one countersunk. The locations of the holes are specified by these dimensions. This dial is attached to a lead screw. By turning the hand crank, the milling machine table with the workpiece may be located with relation to the cutting tool. The workpiece is now being located for drilling one of the holes. There are 3 dials, 3 lead screws, and 3 hand cranks on a milling machine for moving and locating the table in 3 directions. The workpiece has been located for one of the holes, and the drilling is now in progress. The part has been moved to a drill press, and one hole is being countersunk according to the drawing. This hole provides a seat for a flathead screw. This hole is being counterbored. Note the pilot guiding the counterbore. This hole provides a recess for a socket head screw. For this diameter, the engineer has specified a surface finish and tolerance which are beyond the capability of a normal lathe operation. The engineer has calculated that this specification is necessary for correct functioning of the part, but he must also realize that his specification will result in an additional and rather expensive grinding operation. The machinist must determine which grinding wheel to select for this particular operation. There are many to choose from, of different size, grit, abrasive, and bond. The selected grinding wheel is mounted on an arbor. Which is secured to the spindle of the grinding machine. The grinding wheel is dressed to eliminate runout. The workpiece is secured in a chuck and adjusted for concentricity, similar to the lathe operation just shown. Extreme care must be taken in adjustments and setup. Frequent stops are necessary to measure the workpiece to make sure that not too much material is removed. If this happens, the whole piece may have to be scrapped. Note the flow of coolant to dissipate the heat. The dimensions are so critical that the workpiece must be near room temperature when measured. A high degree of surface finish is specified for this flat surface, which necessitates a separate operation on a surface grinding machine. As in the previous operation, the proper grinding wheel must be selected and mounted on an arbor, which is secured in the spindle of the grinder. The grinding wheel is dressed to eliminate runout. Because most workpieces are of iron alloys, surface grinders are usually equipped with a magnetic chuck, which can be magnetized to hold or demagnetized to release the workpiece. The magnetic chuck with the workpiece is moved back and forth under the grinding wheel. At the same time, it moves away from or towards the operator until the entire work surface has passed under the grinding wheel. The difference between a machined surface on the left and a ground surface on the right is readily apparent. Our workpiece is now finished, but the work must be inspected. Some dimensions may be checked with a scale. Other dimensions require a vernier caliper. Critical dimensions require micrometers. What you have just seen is a series of typical machine shop operations, such as turning, grinding, and milling. Every year, improved machine tools are designed, tested, and produced, with even greater accuracy and reliability built into them to meet the ever-increasing demands for precision manufacture. The processes which were shown here are typical of currently used conventional production methods when few workpieces are involved, and this includes the majority of operations. But there are also many instances where larger numbers of units are required. In such cases, there may be opportunities to reduce the total cost of production by utilizing mechanized or automated methods. As an example, this Kearney and Trecker Milwaukee-Matic machine in operation. It is a flexible machining center capable of milling, drilling, reaming, boring, and tapping. It automatically locates and feeds each workpiece, and for each machining operation, the correct tool is automatically selected and inserted in the spindle, and the spindle RPM is changed. It should be noted that the machining operations proper are performed in the same manner as on previously shown conventional machines. As a first step to set up this machine for a new job, a process man analyzes the drawing and lists all operations necessary to produce parts in accordance with its specifications. Next, for each operation, he selects the proper cutting tool and determines the relative position of tool and workpiece, also the proper feed and speeds and type of coolant. Each of these items is assigned a code number, which is translated into holes punched into a tape. The Milwaukee-Matic is equipped with a built-in memory circuit which stores the information transmitted from the tape. All necessary items pertaining to each operation, such as location, tool change, speed, feed, and coolant, are automatically actuated and executed in the correct sequence and at the proper time. Upon completion of the setup work, the labor cost of machining each part using the Milwaukee-Matic concept is considerably less than that of conventional methods. Furthermore, because the cycle repeats itself exactly for any number of units produced, the hazard of human error is virtually eliminated, with resulting lower scrap rates. In cases where repetitive orders are involved, all that is needed for the next lot is to reinsert the previously used tape, mount the required tools in the storage magazine, and furnish material. There are some cases where many thousands, even millions, of interchangeable parts are required, as for instance bearing caps for a series of automobile engines. In such cases, it may pay to engineer a special machine for the job. This casting is to be machined as one unit and then split into a set of bearing caps. This is a schematic drawing of a Kearney and Trecker transfer type machine, especially designed for machining the bearing caps. Castings are carried through 13 stations, and at each station, one or several machining operations are performed. This is a transfer type machine in operation. Notice the transfer mechanism for moving the castings from station to station, and the synchronized motion of the machining heads and tools. This sawing operation is the final one in producing a matched set of completely machined bearing caps. The entire series of operations is automated. But regardless of which method of production is found most economical for any actual case, the part must be made according to a drawing, and the drawing must convey all necessary information to produce the part desired. All engineers who become involved in design, production, and evaluation of any kind must acquire a working knowledge of these principles. And that takes in the vast majority of all engineers.
I can check that gear in a minute, so don't touch anything, okay? Get down from there! Now! Hey! Turn it over! What if it bumped that control by accident? You'd be mincemeat by now. What have I told you? You don't work on equipment when the engine's running.
Well, I told him not to touch anything. All right, I guess I wasn't thinking.
You weren't thinking? You mean you'll work on engines and machinery and not think of your own personal safety? Here. Shake hands with danger.
Shake hands with danger. Meet a man you ought to know. I used to laugh at safety. Now they call me Three-Fingered Joe. I was young and feisty, never did things by the book. Just let me get my toolbox and I'll take myself a look. I climbed up on a dozier with my mechanic's pride. Said, you can keep it running, friend, while I poke around inside. Shake hands with danger, meet a guy you ought to know. I used to laugh at safety, now they call me Three-Fingered Joe. Although I learned a lesson, I forgot it soon enough. The nicks and burns and scratches showed the young ones I was tough. Till another morning I was grinding on some steel. My other hand got careless and fed my skin into the wheel. Shake hands with danger, step right up and say hello. Grinding wheels and metal are what made me Three-Fingered Joe. I've seen mechanics burning and I've seen them take a fall just to save themselves a minute. I've seen them lose it all. I've watched them courting trouble, seen them take a chance and lose. They get careless for a moment and spend a lifetime with the blues. Shake hands with some friends I used to know. Compared to them, I'm lucky to be just Three-Fingered Joe.
So did I show design for manufacture just so I could show Shake Hands with Danger, the new version? I'm not going to say. Oh yeah, probably did. But the thing is, I love those films, those machining films. They're almost like the assembly line footage films in that there's these pieces of metal that go in here and they do this and this kind of like robotic ballet that I really like. The narration, of course, is really, really dry, but Yeah. So that's kind of a niche industry type of film that I enjoy watching. I took drafting when I was in high school too, so some of that resonates with me as far as those mechanical drawings. But thanks for tuning in today. If you like what you saw, you can smash the like button, hit the thumbs up button, hit the notification bell, subscribe, all those different ways to say, yes, we approve of AV Geeks. Even when they show us a 20 plus minute film about machining. Also, if you want to get some more films from our archive, you can go to avgeeks.com, where we have a 24/7 channel running, and other previous shows that we've done there. You can donate at patreon.com/avgeeks. That's a way to support us. And also just buy us a cup of coffee at ko-fi.com/avgeeks. Those are all great ways to say thank you. And let me say thank you for spending the afternoon with us. And we will be back again tomorrow. Sorry I wasn't able to get the commercials up and running. There's lots of problems with that reel. Lots and lots of problems. So we'll see if we can get it up by tomorrow or Friday. But everybody have a great rest of your day. As always, please rewind and love each other. And we will see you again tomorrow. Take care.